Dear friends, for a prosperous world on a sustainable planet, there is, as we've seen today, no science to suggest that the visions discussed today, that the solutions discussed today of a low-carbon future are not possible to achieve. To follow the theme of today, det är möjligt. But the question is, will this be achieved through gradual change, by incrementally tweaking and turning on our current modern economy, or do we actually stand in front of a grand transition at a planetary scale? I would like to share with you the next half hour the story of an holistic scientific reality to make the utopia a reality. To untap the intellectual muscle power of Governor Arnold Schwarzenegger, I believe we need a deep mind shift. We need to reconnect humanity with the biosphere. And the question then is, scientifically, why? Well, it all starts, of course, with the reality that we are on a crowded planet. But we discuss this primarily only as a planetary climate crisis, but in fact we're facing nothing less than a quadruple squeeze on the planet. And as has been alluded today, it all starts with demographics. But it's not the demographics we normally discuss. It's not the fact that we're 7 billion people committed to 9 billion people. It's the fact that it's an inequity driving momentum where it's a minority on the planet, the 20% that stepped onto the industrial metabolism some 150 years back, who's caused the major negative impacts and pressures on the planet so far. Now we see a tremendous positive momentum of the vast majority, a new middle class of affluence largely adopting an unsustainable lifestyle. We have, of course, the climate crisis, which we'll be discussing today, the largest single pressure on the planet. Connie Hedegaard shared with us today that we've reached 393 ppm carbon dioxide concentration. In fact, 2011 marks the year when we've reached, in essence, 450 ppm for all greenhouse gases. We've reached the point, according to the 2007 IPCC fourth assessment, where we're playing Russian roulette with humanity, not with one bullet in the gun, but with 2 bullets. We've come to the point where we have a 60% chance of avoiding dangerous climate change and a 40% risk of failure. As if this was not enough, as if this human disturbance of the energy system was not enough, you would have wished this disturbance to occur on a resilient planet, on a strong planet able to absorb the disturbance. But unfortunately, the first global health control of the world's ecosystems, the UN Millennium Ecosystem Assessment, showed unequivocally that over the past 50 years, we've undermined the ecosystem functions and services on the planet that matter for human well-being faster than ever during human civilization on Earth. So, simply put, we don't only have a climate crisis, we also have an ecosystem crisis. As if these 3 crises or pressures were not enough, we also are learning that nature is not behaving according to the way we've made assumptions in our governance, economic, and societal systems. We always believe that nature is a stock that changes linearly, incrementally, and thereby controllably and predictably. Unfortunately, the universal truth is that nature seems to behave with surprise. Many, many decades of very incremental change can suddenly and abruptly shift to irreversible state changes in ecosystems when systems tip over thresholds. Surprise seems to be the universal behavior of the biosphere. This is a new cocktail for human development. It is so significant that the Nobel Prize laureate Paul Crutzen has suggested that we may have entered a new geological epoch, the Anthropocene, where humanity is the dominating geological force of change at the planetary scale. This has now been published scientifically since 2002, but it only comes into the mainstream much later, and it's only over the last 2-3 years that it really is hitting into the scientific empirical grounds. In just 6-7 months back, we gathered some 20 Nobel Prize laureates and some 30 leading global change scientists to make a state of the art of the human challenge, which was summarized in what we've called the Stockholm Memorandum. The dramatic key message here is that humanity may have reached a saturation point. We seem to be hitting hardwired ceilings at the planetary scale. This is not a doom and gloom message to humanity. It's in fact a message of real strategic ways forward. It suggests that we're the first generation to know that we can today impact the entire planetary system, so therefore with that knowledge we can also act in a transition. It also tells us that we now need to be stewards of the planet to be able to not only manage ecosystems, but also to be able to have a strong planet to deal with disturbances. Climate change is one important, but only one among many challenges facing humanity. And most importantly, there's again no science to suggest that a great transition is not possible and desirable and necessary. Now, I just want to tick off also one key issue here, that we must recognize that most published science today indicates that we've most likely already committed to 2 degrees. And why is that? Well, we've only seen 0.8 degrees Celsius warming so far since the industrialization, but we also know that dramatically and cynically that air pollution is in fact helping us, because when we have sulfates and nitrates and smog in our big cities, they reflect and function as mirrors reflecting income and solar radiation. So the cynical reality is that one major challenge for humanity, climate change, is camouflaged by another major environmental challenge, namely air pollution. If we clean our cities, we may have very rapidly 1 more degree warming already in the pipeline. The second issue is that we just measure warming in the atmosphere. But in fact, 90% of the warming so far due to anthropogenic injection of energy-absorbing greenhouse gases is taken up by the oceans. So the oceans play this enormous role in buffering warming so far. And finally, can you believe it? The planet is being our best friend so far, absorbing roughly half of all our emissions of carbon dioxide in terrestrial ecosystems and in the oceans. So we have this world's largest free ecosystem service operating for the modern economy. These 3 issues are today playing in our favor, but as I'll show, they cannot be counted on into the eternal future. As Connie already referred to, last week, the IPCC showed for the first time the summary of something that scientists until recently were never willing to make the connection. You would never have a scientist with a microphone down his or her throat to say, yes, this extreme storm or this extreme drought is connected to human-induced climate change. From now on, 2011 is the tipping point. We're starting to see that we have so much statistical observation today that it is impossible to delink extreme weather events from anthropogenic climate change. And this is a turning point in our knowledge. We're so used to seeing these front pages when it comes to turbulence and shocks in the global system. This is, of course, the financial vortex when Lehman Brothers collapsed. In May 2011, The Economist welcomes humanity to the Anthropocene. This, in my mind, is an enormous achievement, an enormous help for humanity in innovation and transitions towards a vision of a sustainable future. The drama is, of course, that these 2 front pages are interacting in real time in the world. I find it just enormously remarkable to have the insight that increased oil prices increased oil prices to $130 US per barrel, 130% increase in phosphorus prices, droughts after 12 years of drought in Australia, one of the world's largest exporters of cereals, forest fires in Russia leading to protection of borders on the global cereal market, influenced food prices in the entire Arab Spring region, putting momentum into the revolution that, of course, started with young people, internet connected, in repression after decades and decades. We're starting to see social, ecological disturbance occurring at the same time. The Economist, the typical sharp British understatement journal, made the following citation, which I think communicates exactly where we're in. When reality is changing faster than theory suggests it should, a certain amount of nervousness is a reasonable response. This is exactly the situation we're in, which of course is a way to induce change. Well, where's the proof? Well, the proof is, of course, in the exponential change that we all know so well. This is the classical hockey stick pattern that we've all learned to know. Since 1750 until today, we have the exponential growth of carbon dioxide. But I can tell you that it doesn't matter which parameter you pick that forms the basis of human well-being and economic growth, they look the same. This is the sister, temperature rise. But look at this. This is nitrogen oxide from modern agricultural systems and industrial processes. This is methane when we drain out all our wetlands to form the basis for modern agriculture. This is stratospheric ozone depletion. It's starting to bend, but barely. This is the frequency of natural climate disasters. This is overfishing of the oceans. We've lost roughly 80% of our fish stocks on the ocean. This is the eutrophication crisis on the planet, which is all about eutrifying our freshwater systems and coastal zones. Deforestation, expansion of agricultural land, and as was alluded to earlier, we're in the 6th mass extinction of species on the planet. So we have a multiple pattern which form the basis of evidence that we are in the Anthropocene. Science, the world's second most prestigious scientific journal in the world, published a whole special issue on the indicators of the Anthropocene. And they all look the same. And I just want to refer to you to the upper hand corner here, which is the risk that under continued business as usual, we're acidifying the oceans so fast that we cannot exclude a collapse of the marine tropical coral reef systems. Because what happens is that when the oceans absorb carbon dioxide, it's high school chemistry that carbon dioxide reacts with water, creating carbonic acid. Carbonic acid reduces pH, but snatches carbonates out of the water, which means that all marine life loses their Lego blocks of building their skeletons and shells, which is calcium carbonate. So the oceans in the world, in the ocean's efforts of helping us to stay stable, are causing a drain of the building blocks of all marine life. The Arctic Ocean in 2008 became corrosive to calcium carbonate due to anthropogenic emissions of climate change. Now, we have a sister of these anthropogenic hockey stick patterns, of course. And I just want to share this one, which may be the most important one, which is to show you that over the same period, we have 3 billion people suffering from water scarcity. And we know that water will be the parameter hit first when it comes to anthropogenic climate change. And all the dotted lines here are our efforts of exploiting and tapping and storing water behind dams. So even though we're doing tremendous efforts, we're still in a world that is not really keeping momentum with our positive developments. And finally then, this is how it looks like. You don't need to look at all the parameters here, but you see the pattern, that the world looks like this when it comes to the pressures on the planet. Something happens synchronously 10 years after the Second World War. We're 3 billion people. 10 years after the Second World War, we put in high gear of the industrial metabolism. This is the point that science today calls the point of the great acceleration of the human enterprise. This is when we take off. And today we have empirical evidence that we are at the top here. Now, you know, all of you, that the first warning came here. This is Rachel Carson's seminal book, Silent Spring in 1962. The first warning to humanity that we now need to be stewards of the biosphere to avoid risks. This is when the Club of Rome releases its limits to growth. As you all know, these were shut down by conventional economists, by policymakers. This was neo-Malthusianism. Well, I would argue that perhaps we can excuse them. Because look at where we were. We had barely started the journey. You could never really predict where we're heading. But today, we're up here. There's no excuse for inaction today. Today we have so much robust evidence that even if there's uncertainty surrounding every individual of these curves, when you put them all together, the number of, or the volume of uncertainty reduces to a very low amount. But most dramatically, if you enter the disciplinary science in oceanography, in ecology, in climatology, in stratospheric ozone chemistry, they all indicate that we need to bend the curves this decade. Why? Not because the world will go under the 1st of January 2021, but because we've learned that due to the risks of tipping points, that we may unleash feedbacks that can play out irreversibly over a long-term future. That it's now we're deciding the outcome for the modern world in the century to come. Now, unfortunately, dear friends, it's not enough to just have this complexity in our back pocket about the pressures on the planet. We also need to recognize then the advancements of nonlinear change and multiple stable states in social ecological systems. Now, this may sound very complicated, but it's quite simple, in fact. We've assumed that the world behaves in the upper left-hand corner. Linearly, when we put pressure on a system, it changes incrementally linearly. We're learning more and more that we have tipping points and that, in fact, systems like savannas, wetlands, forests have multiple stable equilibria separated by thresholds. And when you push a system too far, it may tip over and change character. Now, we're starting to build up such a knowledge base on these tipping points. And we often illustrate this to our students and to policymakers in the following way. The system is in the little ball up there, an ecosystem like a forest, a wetland, an inland lake. And the resilience of the system, the strength to stay stable and deliver well-being, is defined by the depth of the cup. So we have desired states for our coral reef systems, our clear water systems, our savannas, and we use them, and over decades we erode the resilience and the cup becomes more and more shallow. We are lulled into a comfort zone because they continue to give the appearance of being healthy. But they become more and more vulnerable to a trigger, such as a flood, a disease, a drought, and the system tips over. And the reason why we have a state change is that we have a feedback. A feedback that for coral reefs is that soft corals take over, they are self-eutrifying, and the system becomes a soft, slimy coral system. We have evidence today to show that when you lose the top predators like cod, they hit down the food chain and thereby accelerating a shift to oxygen-free algal bloom-dominated systems. And for savannas, it's so clear, as with forests, that you can dry out systems so they get self-desertified. So we're always looking for feedbacks to understand these dynamics. The drama is that for 30 years, this science was mostly in local ecosystems. But now we're seeing that this is moving up the scale. This is the curve you may have seen, which is the dramatic decline of the extent of summer ice in the Arctic. Now, science has been trying to predict the change in ice extent for many, many decades. And it's been assumed to change quite predictably and linearly. But you all read, I'm sure, what happened in 2007. In 2 months, 30% of the ice cover was lost abruptly and to science as a complete surprise. I can share with you that 2011 will be another low point for the Arctic ice. The drama is that we know the feedback. This is how we would like the Arctic to look like, as a white surface reflecting incoming solar radiation. But when we suddenly lose a very large portion of summer ice, the whole system changes color, it becomes absorbing of solar energy, and it self-accelerates into a melted state. Now, nobody knows if the Arctic has tipped over yet, but what we seem to know is that the Arctic is a regulatory system which, if we would lose its summer ice, could contribute to another degree warming because it is a biome regulating the temperature on the planet. The other hotspot system in the world, in my mind, if the Arctic is one of them, are the coral reefs on the planet. These are the canaries in the mine warning humanity of the direction we have to go. In the 10-year update of Reefs at Risk from the World Resources Institute, the drama is that now we're seeing that reefs are not only subject to warming, but also to eutrophication, overfishing, and unsustainable tourism. So the system that we would like to see like this, that deliver well-being for 250 million people at coastal regions around the world, are increasingly showing this kind of tipping point. And when they move over to this state, we lose their ability not only to deliver human well-being, but believe it or not, we now start learning that they also lose part of their capacity to absorb carbon dioxide and be a buffer point for our emissions of greenhouse gases. So biodiversity is the toolbox also to deal with climate change in real sense. Now, more and more modeling is therefore looking at the risk. How do you get tipping points into the climate models? I mean, you may not believe this, but all the big climate models forming the basis for our climate policy do not include tipping points. They do not include nonlinear change. There's no climate model in the world that actually includes even albedo change when ice changes color when it melts. Now, when you start building up a new generation of models into the fifth assessment, we start seeing this pattern. This is modeling from the Potsdam Institute for Climate Impact Research up until 2300. It seems more and more likely that we've reached a point where we are really at the choice between a safe future, which is possible under 2 degrees, or a future where we very rapidly may trigger these kind of tipping points and feedbacks that may take us unequivocally towards a warm state of 5-6 degrees. Now, I want to emphasize that 5-6 degrees warming is a world that we do not recognize. There's no evidence to suggest that a planet of 5-6 degrees can even be close to supporting the world as we know it. Over the last 30 million years, we've only seen variation in the order of 4-5 degrees Celsius. Okay, so what happens then to guide humanity here in the Anthropocene when we have the inside of the Anthropocene connected with the risk of catastrophic tipping points? Well, we asked this question to some 40 leading global environmental change scientists. Say, how does this change the agenda for global sustainability in the Anthropocene? Do we now have to, for the first time ever, put the planet into the pot? Do we have to ask ourselves, are we threatening the stability of the entire Earth system to support the modern economy? Well, to answer this question, of course, you need to start by answering the following delicate question. What is our desired state? What's the desired state of the planet to support us as 7 billion people on our way to 9? Well, surprisingly or not, it's quite easy to answer because of the fantastic glaciology we've seen in Antarctica, Arctic, and Greenland over the past 20 years. And this is an extract of that to illustrate it. This is the last 100,000 years. It's a very significant period because we've been modern Homo sapiens for roughly 200,000 years on planet Earth. On the y-axis here, you see a good proxy for living conditions, which is temperature. This is the period when we've had the same ability to develop civilization as we have today. Ladies and gentlemen, this was indeed a jumpy ride for humanity. We go up and down in extreme weather events. In fact, the low point you see at 80,000 years there is a cold point where most fresh water is tied in the poles. And modern DNA-based archaeology points out that we may have only been 15,000 fertile adults left on the planet at that point. And we're only hunters and gatherers. We're 20 to 40 million people. We have, to put it simply, a rough time until we enter the extraordinarily stable state of the Holocene. We barely enter the Holocene, and what do? We invent agriculture. We domesticate animals and plants thanks to the fact that suddenly the planet stabilizes in a, for us, conducive state. And we go into the civilizational journey we all know. We're 3 billion people at the Great Acceleration. We're today 7 on our way to 9. Our conclusion is that the Holocene is our desired state. There's no other state that we know of that can support the modern humanity as we know it. Temperature varies in the Holocene with plus minus 1 degree. Plus minus 1 degree. Okay, when you do that, you then ask science to answer the question, so if we know that the Holocene is our desired state, what are then the Earth system processes that we need to be stewards of to remain in the Holocene? And can we, for each of these, define the catastrophic thresholds we don't want to induce, and even quantify a boundary, a point upstream of the threshold within which we can provide a safe operating space for humanity? We call this framework posing planetary boundaries for humanity. And what is important here is that this scientific group of leading global change scientists, from Nobel Prize laureates like Paul Crutzen to Jim Hansen, who was referred to earlier as the leading climate scientist from NASA, suggest that there are 9 planetary boundaries. If we can be stewards of them within a safe boundaries, that we can in fact have a transition to a safe future, where perhaps even Arnold Schwarzenegger can remain having his 6 cars, or was it 7 or 8? Which is something that is to say that within a safe operating space, we can have a myriad of different governance and societal development pathways. The point here to you is to convey that science is today able to quantify safe boundaries, and that climate change is but one among many boundaries that we need to respect. And interestingly, they interact. Essentially, all of these matter for climate change. It's so significant, in fact, that we're starting to see that the final battleground, if we're going to be able to stabilize climate on 2 degrees, is no longer only about reducing emissions. It's also about being active stewards of nitrogen, phosphorus, land, fresh water, air pollution, and biodiversity. What this enables us to do is to create a safe operating space, shown here in green, and where we can measure where we are. And the first analysis, published in Nature 2009, indicates that we have already come into a danger zone on biodiversity loss, on climate change, shown not least in the Arctic, but also on our interference with the global nitrogen cycle, which leads to eutrophication and release of nitrogen oxide, which is in itself a greenhouse gas. But it enables us to provide a guidance of how to return into a safe operating space. Now, just to illustrate with you, what does this all mean in terms of linking climate change to global sustainability? Well, this is one way to illustrate this. This is our emissions curve since 1960 until today in billion tons of carbon. This is carbon dioxide. As has been alluded to today, you see the last little very, very rapid increase in the end there. That's since 1997. So during the time since we signed the Kyoto Protocol, the first time we ever tried to sort out and solve this problem, we have a faster than ever emission during this whole journey. Now, because carbon dioxide is a long-lived gas in the atmosphere, in fact, recent science indicates that the effects last not 150 years, but even 1,000 years, you would think that it's a surface under this curve that has led to 0.8 degrees Celsius warming so far. As I referred to earlier, that's not the case. In fact, oceans and land absorb half of these emissions. So in the end, it's only the gray surface here that remains in the atmosphere that has caused warming so far. But look at this. It's not only that the planet is helping us to take out half of our emissions, it has also increased and doubled over the past 50 years. So the estimate is that in 1960, the absorption was 2 gigatons, and today it's 4. which prove that the planet, with its biogeochemical interactions, are doing everything it can to remain in the Holocene state. The resilience theory holds. The planet tries to stay in its desired cup and does not want to push ourselves out of the threshold. However, recent science indicates that this buffering capacity may be going down, both in the oceans and on terrestrial ecosystems. So we now need to move fast on connecting the biosphere stewardship with climate change. Now, what journey do we then have to take if we take this scientific update seriously? Is 50% enough? 80% enough? Well, most science, credible science, indicates that we need to follow this pathway. That if we were able to turn the global emissions curve by 2015, which today is really utopia, we would have to have a carbon-free planet by 2050 to have a 70% chance to stay under 2 degrees if we incorporate the risk of losing parts of our sinks and if we take tipping points seriously. If we would push this point to 2020, then we need to decarbonize by 2040. That pace of that curve is 8 to 10% per year. Now, there's no science to indicate, there's actually no analysis to indicate that we can do that. So the blue line is at 6% per year, and it seems to be the most rapid, revolutionary pathway that technology could support for 196 countries on the planet. So this is what we're facing, which supports action towards a sustainable future. Now, I just want to share with you finally one dimension which is so often forgotten. So here we have the curve. This is in fact not even the recent curve. This is the IPCC curve of 80% reduction. Well, let's assume that all the OECD countries do exactly what they promise, which none have done yet. I will actually admit that not even Sweden has done it, because even though we report a reduction of 7%, we've, in our consumption and net imports, actually increased our emissions with roughly the same amount. But let's assume we actually do exactly what we promise. The remaining part of the curve here, this part, will have to be done by the world's majority, the world's poor countries. It means that we have no choice. Actually, even developing countries need to decarbonize very rapidly if the world is to stay below a safe future. We've done an analysis in a framework we call greenhouse development rights, where we simply try to analyze very coldly what does it mean if we are serious about equity in the world, to give space for development for 9 billion people, and stay under 2-degree curve. And this is the result. And I share Sweden here because I thought I'd be a little bit self-critical, which shows that by 2020, Swedish emissions would have to reduce not by 20, not by 30, not by 40, but by remarkable 120%. Now, this is the cold analysis of if we're to stay under 2-degree curve, we have a population growth, and we just assume the simple fact that everyone below an income of $4,000 per capita has a right to increase his or her emissions of greenhouse gases to have energy access over a transition period into a safe future. So we have no choice, we've discussed that a lot today, to do everything we can domestically, plus invest in other countries. This suggests a fantastic mechanism to quantify in million tons of how much investment Sweden should do in developing countries. I can tell you that the curve for Norway looks roughly the same. Okay, so coming to my last round off here, what positive stories can be told? Today, a lot of discussions are focused on energy. I'm a lead author in the Global Energy Assessment. Many leading energy analysts in Norway are part of this, which will be released very soon. And the conclusion is that the world can, in fact, achieve a renewable energy revolution with energy access to all by 2050. So that's one part. But I would argue that perhaps the second largest priority is to rapidly transition towards a sustainable production of food on planet Earth. Because agriculture is the individually largest emitter of greenhouse gases. 30% of our emissions come from food production. And 40% of the world's surface is under one or other form of agriculture. And agriculture is the largest driver of loss of biodiversity. So here we have a tremendous problem, but also tremendous untapped potential, because there's nothing to suggest that agriculture could not turn into a sink of carbon rather than being the largest source of carbon. We recently produced the first ever analysis of can we feed the world while meeting global sustainability criteria. And our conclusion is that it is possible by using innovations in technology and concluding that we simply need to boost productivity in many of the most poor regions in the world by using modern commercial fertilizers and modern geotechnology. However, the threat here is, of course, if we push the water cycle impacts of climate change too far. So to round off then, in conclusion, I started off suggesting that, well, perhaps it isn't all too bad to understand the deep, deep risks, because to unleash the potentials we've been talking right through this day, I believe we need a deep mind shift. We need to reconnect to the biosphere. And that is one starting point for what has to be a global transition. We cannot do this through incremental change. And of course, it's fantastic then to couple this mind shift of reconnecting to the biosphere with what I think is the theme of today, which can perhaps be, in a way, summarized in what you've probably seen in this cartoon, which is perhaps it doesn't really matter all that much what science tells us. There's so much evidence that we are creating a better world by moving forward on all the innovations that we've been discussed today. But I think the connection between science and innovation is absolutely critical. Thank you.